Okay, hey everybody, let's get started. All right, so let's start with section 2.5. Sorry, one sec. Okay. All right, so in this section, we're going to talk about the graphs of several functions and how something called transformations. And so basically what we want to know how to do is to say if we're given an equation like something like this, we want to know how can we graph this quickly, or maybe not necessarily quickly, but how can we graph this in an easy way? In this example in particular, by using this equation, just x squared. So let's go through this example. I guess before, maybe we should talk about some rules. Let's see, how can we do this the easiest way? Okay, so let's say we have, let's erase this for a second. Let's call this rules for transformations. So maybe at first these rules won't make too much sense, but after doing several examples, maybe the rules will start to clear up a little bit. So say if we want to graph this equation, let's say f of x plus b yeah, let's do this for now. X plus b, maybe we could do then a plus c at the very end. So in this problem, this a and this b and the c are going to tell us to do something to the graph of f of x. So how we graph this is what we're going to do is first we take the graph of f of x. So, when we take the graph of f of x, just maybe a quick example of what it could look like, something like this. And we have points. So say if this is just an x value, this is the point x f of x. Or like we said before, another way of thinking that point is just x comma y. So when we do this thing like this is going to be the graph of f of x. So this is the function we now want to graph. We're going to multiply a in the front of f of x. We're going to add b directly to the x, and then we're adding c at the very end. So those a, b's, and c's are going to do some things. And what it's going to do is going to manipulate this graph, the graph of f of x. And so in this example right here, what this a is going to do, let's say it like this. So what this a is going to do, all we do is we take all of our y values and we multiply them by a. So take all the y values. And multiply by a. So whatever that number a is. What that b value is going to do. So what we're going to do is we're going to take all of our x values and subtract b from them. So take all the x values. and subtract b. And then in this example in particular, we'll take our c value. And what that's going to do is we're going to take all our y values and add c to them. So what we're going to do is add c to all the y values. So if we're given in this form right here, this is these three things below the a, the b, and the c. That's what we're going to do to the graph to change it around. So let's do a number of examples with this. And also we'll talk about this in the example actually. All right, let's start with how about like number let's see which ones we got here. Let's just start with number 1. We'll change the directions from the book a little bit. This one, it is telling you to graph it. Okay, so for number 1, what it wants us to do is graph f of x is equal to x minus 3 squared. So but the first step that we do for all these problems is we need to find something called the parent function. In this example up above, f of x is called the parent function. So maybe we can make a mention of that. So f of x is called the parent function. That's only f of x in this part. F of x down here, this f of x is not the parent function. The parent function is going to be the function that we're doing the a, the b, and the c thing to. So the way that we find the parent function, given any problem, so the first step here, we need to find the parent function. And the way we find the parent function is you just get rid of every single number that is not an exponent. So what we have to do here, this is sort of just like an easy way to kind of remember what to do. So we need to remove all the numbers that are not exponents. Okay, so in this particular, let's rewrite the thing. What we're trying to graph is this. F of x is equal to x minus 3 squared. So the first thing we need to do is find the parent function. Okay, like we said above, we have to get rid of every single number that's not an exponent. The only number we see is this minus 3. So we're just going to get rid of that number. And what we're left over with is just this x and then the power of 2. So the parent function here is just going to be x squared. And so now what we want to do, we need to figure out what are all of the things that are changing to it. And we're going to do it one by one. In this problem, only one thing changes. All we're going to do is have this minus 3. So our first transformation that we're going to do is just going to be x minus 3 squared. And then we stop at our transformations once we get to the equation. So this is all we have to do here. We're starting with x squared and we're turning it into x minus 3 squared, since that's what it wanted us to graph, x minus 3 squared. So how we graph these now is we start with the parent function. So this is something we used to have memorized. We have to have memorized what x squared looks like. So we know x squared looks like this. Let's start down here. X squared makes the parabola shape. And now what we need to do is put 3 points onto the graph. There's several ways we can do it. I guess the best way, let's just make an xy table. So here's x, here's y. And here y is equal to x squared. Say if we plugged in minus 1, we're going to get positive 1, since minus 1 squared is 1. If we plug in 0, 0 squared is 0. And if we plug in 1, 1 squared is 1. So we'll have these points on here. We'll have the point minus 1, positive 1. Okay, and then we have the point 1, 1. And we have the point 0, 0. And so here's the parent function. Here is the graph of x squared. So now we want to graph x minus 3 squared. So that's going to be our only transformation, but that's the thing that we wanted to graph, x minus 3 squared. So in order to graph x minus 3 squared, let's see what's changing here. Well, let's look at above. We have these a, b's, and c's. So this a in the front, it means something is multiplying on the outside of the x. If we look down here, there's nothing multiplying on the outside of the x. If there was, it would look like this, like a 3 or something out here. But that problem doesn't have that. So we don't have an a. Okay, but let's see, plus b, is there something being added directly to the x? And in this situation, the answer is yeah. You see, we have this minus, whoops. We have this -3 being directly added to the x. So we do have a b, but we don't have a c, a number added. See here, a number added to the outside of the x. There's nothing added on the, if there was, it would look something like this, like a +2. So in this example, all we have is something being added directly to the x. And so we look above. So what does it mean that when we have something added directly to the x? Well, if you look up here, it says you take, that's our b value. We take our b value. Oh, what just happened? Sorry, 1 second. What we do is we take our b value, if you look right here, and whatever that b value is, we subtract it from the x, all of our x values. So what is our b value here? Our b value is -3. So what we have to do is subtract -3 from all of the x values. But subtracting -3 really means just adding 3. So what we need to do is we take all of our x values in the previous graph on those points, and we're going to subtract -3 from them. But again, when we're saying subtract -3, that just means add 3. So what we have to do is add 3 to all of our x values. So this point right here has an x value of 0, but if we add 3 to it, now it has an x value of 3. So it's going to be 3, 0. And we're not changing the y values. We're only changing the x values here. If we take this point over here that has the -1, if we add 3 to that, it becomes 2. So here's 2, 1. And then the other one, 1, 1, if we add 3 to it, it's going to be 4, 1. Okay, then we connect the dots. And in this particular example, that's all we have to do. There's no other transformations to take care of. So this is how we would graph x -3 squared. So what we do is we start with a graph that we know how to graph easily, the x squared, and then we just apply the transformations to it. Let's do another example. Let's do number 15. Okay, so number 15 says we want to graph g of x is x plus 1 squared minus 1. All right, so just like before, the first thing we need to do is find the parent function. So here's our parent function. So our parent function here, like we said before, all we do is we look at our equation and we get rid of every number that's not an exponent. So we get rid of this number, and we're going to get rid of that number. And all we're left over with is x squared. So our parent function is going to be x squared. So now we have two things doing. You see how we have something added to the x and something added to the outside of the x. So we have two transformations. And we always start with the one closest to the x. In this situation is going to be this +1. So our first transformation, that's going to be the x plus 1 squared. And then the last thing is subtracting the -1 on the outside. Okay, so there's, so in this problem, we're gonna have to have three graphs. We'll have a graph of the first function, or the parent function, and the first transformation, and then the second transformation. But our second transformation, this thing is exactly what we wanted to graph. So we're gonna stop right there. Okay, so let's start with the parent function, x squared, which we graphed last time. So we saw I just did a parabola, and then we put these 3 points on it, the -1, 1, the 0, 0, and then 1, 1. So here's x squared. Okay, so now let's move on to the first transformation, x plus 1 squared. So here we're adding a number directly to the x value. So if we look above, that means we need to subtract all of the x values by that number. So the number we're adding is 1. So we need to subtract 1 from all of the x values. So previously we had the point 0, 0. If we subtract 1 from the x value, now we're going to have -1, 0. We had the point 1, 1. If we subtract 1 from the x value, we're going to have the point 0, 1. We had that point -1, 1. If we subtract 1 from the x value, we have the point -2, 1. And then we connect the dots. Okay, now we move on to the last transformation, which is x plus 1 squared minus 1. Let's move down here. So now what we're doing is we're subtracting a 1 from the outside of the x. And if you look above, when we subtract 1 from the outside of the x, that means we take all of our y values and we subtract 1 from them. So here we have this y value minus 1, 0. Our y value is 0. If we subtract 1, we're going to get a y value of minus 1. So down here, minus 1, minus 1. Here we have an y value of positive 1. If we subtract 1 from it, we get 0. Nothing changes to the x, so the x still stays 0. So now we have the point 0, 0. And over here we have minus 2, 1. Subtract 1 from the y value, we get minus 2, 0. Okay, and then we just connect the dots. And so this would be it. This is the equation we wanted to graph. And so this is how we got there. So this example, we have to do 2 steps. So we start with x squared, then we move to this one, and then we use the rules to move to the last one, which ends up being the answer that we needed. Okay, let's do some other examples. We do number 12. Okay, so for this example, we want to graph this function. So minus absolute value of x plus 2. So just like always, we start with the parent function. So we get rid of every single number that is not a exponent. So we got to get rid of this minus sign and we got to get rid of this 2. So our parent function here is just absolute value of x. Okay, now we do our first transform. We have 2 transformations here. You see how we have a minus 1 multiplied in the front, and then we have a plus 2. And we always start with the thing closest to the x value. So we're going to plug in the minus 1. So that's going to be our first transformation. And the second thing we're going to need to do is take care of the plus 2. So we have our minus x and then plus 2. So let's start and graph each one of these things separately. So starting with our parent function, we can make an xy table for this one. Let's do x, y is equal to that. If you plug in minus 1, the absolute value of minus 1 is 1. If you plug in 0, the absolute value of 0 is 0. If you plugged in 1, the absolute value of 1 is 1. And also something to just the general shape that we need to have memorized, it's like a V shape for the absolute value of x. So it's not a parabola, even though it has those same points as the x squared like we had above. Just it happens that the absolute value of x looks like this. It's a V shape. So we have these points, 1, 1, and then minus 1, minus 1, positive 1. Okay. So here's the graph of absolute value of x. So now we move on to our first transformation, that minus absolute value of x. Okay, so let's go back. Well, we haven't done a multiplying one yet. So if we go back to the chart up above, it says, so here, that minus sign takes kind of place of that letter A. So if you see A, it says we take all of our y values and we multiply it by that number. Okay, so we're going to take all of our y values here, and then we're going to multiply it by that minus 1. So let's start with the 0.00. The y value is 0. If we multiply that by minus 1, it doesn't changes, so it still stays at 0. The point on the left, the minus 1, 1, if we take the y value of 1, multiply it by minus 1, it turns into minus 1. So that point's going to come down here as minus 1, minus 1. Because again, the x value doesn't change. The x value stays minus 1. All we do is we multiply by this y value by minus 1. And then the point on the right, so the x value is 1, that's not going to change. But that positive 1 for the y value, we multiply it by 1. And then we multiply that by minus 1, so it turns into minus 1. So we'll have 1 minus 1. Okay, and then we connect these dots with that same like V shape. Now we move on to our last transformation, which is adding the 2. So let's move down here. So this is going to be minus x plus 2. So this is, we're adding a 2 onto the outside of the x. So that means we take all of our y values and add 2 to them. So let's start at the origin. We have that point 0, 0 right here. What we need to do is add 2 to the y value. So it's going to turn into 0, 2. Here on this point, we have a y value of minus 1. If we add 2 to that, that becomes a y value of positive 1. Here we have a y value of minus 1. Add 2 to that, it becomes a y value of positive 1. So the x value stays the same, remember? So the x value is still minus 1, but our y values now become 1 because we added 2 to the previous one. We added 2 to this minus 1 right here. All right, then we connect these lines, or connect these dots with the V shape. And so this will be our graph that we're looking for in this problem. Okay, how about let's do number 20. It's number 20, say. So we have f of x is equal to minus 1/2 square root x minus 1. Is that correct? Yep. All right, so we got, let's first find the parent function and then the transformations. So our parent function, we get rid of all the numbers that aren't a square root, or sorry, all the numbers that aren't an exponent. So that's not an exponent, get rid of that, and that's not an exponent, so we get rid of that. And all we're left with is the square root of x. So our parent function is going to be square root of x. And then we start with all the things closest to x and move outwards. So that minus 1 is closest to the x. So our first transformation that we're going to do is square root of x minus 1. And the second thing is we're going to multiply the minus 1/2 in the front. All right, so we got these things to take care of. So let's start with the parent function. So again, for the parent function for all these, you sort of need to have the general shape memorized. So we know square root of x, it starts at the origin, it doesn't go anything to the left, and it just looks like this. Kind of like this shape that gets more and more flat as time goes on. So we need to find just a couple of points to put on there. So let's make an XY table. If we plug in 0, the square root of 0 is 0. So we see that at the origin, we have the point 0, 0. 1, the square root of 1 is 1. So we know that there's 0.11 on there. And something that we want to plug in a point that we could take the square root of easily. So maybe we could plug in like 9. Square root of 9 is 3. So we have this point over here at 9, 3. So here's 3 points on the graph of square root of x. So let's move on to the first thing, square root of x minus 1. Okay. So what are we doing here? Well, we have this minus 1. I want to, oh no, this is fine. No, it's not. I want to move this line over a little bit. So we have that, we're subtracting a minus 1 from the x. So if you remember, whatever that number, that technically what we can think of this as we're adding a negative 1 to the x. But regardless, so that number is a minus 1. So what we need to do is take all of our x values and subtract that number from it. So we're subtracting a minus 1, which means we're adding 1. So with this minus 1 here, it means we're going to add 1 to all of the previous x values. So there's this x value of 0 right here. So that's now going to become an x value of 1. We have 1, 0. The y value doesn't change. That's why the y value is still 0. Up here, we have an x value of 1. Add 1 to that, it becomes 2. 2, 1. And here we have an x value of 9. You add 1 to that, and you get 10. And the y value doesn't change, so it's still going to be 10, 3. So the y value is still 3, but the x value just changes. Let me connect these lines with that same shape, or connect the dots, and so we have this now. Now on to the last one. We are now doing the -1/2. So -1/2 x minus 1. Okay, so this -1/2, we're multiplying it on the outside of the x values, which means we take our y value and we multiply it by that number. So we take all of our old y values and we multiply it by -1/2. So let's start here at this first point, 1, 0. The y value is 0, so nothing changes. 0 times -1/2 is still 0. So this is going to be 1, 0 still. Our next y value up here, 2, 1. So that y value is 1. If we multiply it by -1/2, it turns into -1/2. So now that point's going to move down here. The x value stays the same, but now we're going to have -1/2. And here the y value is 3. We multiply that by -1/2, it turns into -3/2. But the x value stays the same. So the x value is still 10, but now the y value moves down. It's negative, so we have 10 minus 3 over 2. Then we connect them with that same shape. Okay, and then so for this example, then we'd be done. This is what we need to graph. All right, we do several more. Let's do 33, that's a good one. So this is going to talk about the idea of an asymptote. Let's first start, what we want to do for this problem is graph f of x. This one doesn't actually, the directions for this part of the problem doesn't tell us we need to graph it, but let's graph this one anyway. So f of x is equal to 1 over x plus 3, 1 over x plus 3 plus 2. So first, let's find the parent function. So we have to get rid of every single number that is not an exponent. So that's not an exponent. We're going to get rid of the 3, and we're not going to. That's not an exponent, so we're going to get rid of the 2. So our parent function is just 1 over x. Our first transformation, the thing that happens closest to the x, is we're adding 3 to it. So 1 over x plus 3. And our second thing, we add 2 at the very end, so 1 over x plus 3, and then we're going to add 2. So again, just have 3 graphs. So we have to start with the graph of 1 over x. So again, just like how all these are, we need to just have memorized what does 1 over x look like. So 1 over x makes this shape. It's like this corner that's like smooth over here. And then also down here, it does the same thing. Let me draw that better down there. Sorry. Okay, so we have, this is what the graph of 1 over x looks like. What's important is these asymptotes. So this graph gets really close to, so here's the y-axis, here's our x-axis. Let's move y to the other side so we don't get confused. So here's our y-axis, here's our x-axis. The graph gets really close to the x-axis over here, but never touches it, and the graph gets really close to the y-axis up here, and it never touches it. So that's important to keep in mind. And same with down here. The graph gets really close to the y-axis as it goes down and down and down, but it never touches the y-axis. And the graph over here, as we keep going, it gets close to the x-axis, but it's never going to touch the x-axis. So when we're shifting this graph around and stuff, we have to kind of keep that in mind. So this is just 1 over x. Now let's put, just like last time, let's make a little xy table. So what happens when we plug in 1? Well, we're going to get 1. Now let's just do 2 points. And if we plug in -1, we're going to get -1. So that point right there is 1, 1. And this point right here is -1, -1. Okay, so here's 1 over x. So the first thing is 1 over x plus 3. So we need to add 3 to the bottom, which means we're going to subtract 3 from all of our x values. Okay, so here's our new graph. So now we're doing this one, 1 over x plus 3. So remember, we're adding 3 down here directly to the x, which means we need to take all of our x values from the previous graph and subtract 3 from them. So here we have an x value of -1. If we subtract 3, now we have an x value of -4. So over here at -4 minus 1. Here we have an x value of 1. We subtract 3, that becomes -2. So up here at -2, 1. So now we got to think about those asymptotes. So we had this asymptote over here on the y-axis. This was an asymptote. So when we say subtract 3 from the x values, that just means we're shifting everything over to the left 3 units. So what we're going to do is we're going to take that asymptote that was originally the y-axis and shift everything over to the left 3 units. So now we're going to have this asymptote over here. And this is going to be a y value of -3. So then, but notice all we're doing is shifting to the left and to the right. So we also have this asymptote down here on the x-axis. But if we shift that horizontal line to the left, it's still just a horizontal line. It doesn't change anything. So that's not going to change much. So now we're still going to get close to the x-axis. Because basically all we did, this line goes on forever. So if we shift it to the left, nothing really changes. It's just like moving this to the left, but nothing happens because it still goes on forever on a vertical line. So what the graph is going to look like now is this. So we're going to get close to this new dotted line. And then we're still going to get close to the x-axis as time goes on. And same with down here. So still get close to the x-axis. And then it goes down forever in this direction. Okay, so there's 1 over x plus 3. So now our last one, let's move down here. We need to do 1 over x plus 3, and then we're adding 2. 1 over x plus 3, adding 2. So now we're adding 2 on the outside of the x, which means we take our y values from the previous graph, and we add 2 to all of them. So, sorry. So here's an x value, or here's a point, -4, -1. We take our y values and add 2 to them now. That y value there is -1, so now that y value is going to move up to here at +1, because we're adding 2 to it. So we'll have -4, +1. And then our other, where was it at? Here, it was the point -2, +1. If we add 2 to that y value, now it becomes a 3. So that's going to be the point -2, 3. Okay, so now let's think about it. We used to have this vertical asymptote. We're adding 3 to everything, means we're just shifting everything up 3 units. Now in this situation, if we shift a vertical line upwards, nothing changes. It's still a vertical line moving upwards. So we're still going to have that same asymptote. So we're still going to have our asymptote right here on, this was -3. We still have that same asymptote. However, remember that on the previous one, this was an asymptote, the x-axis, but we're shifting everything up 2 units. So we're going to shift that up 2 units. And now if it was at 0, now it's going to be at 2. So there's going to be the new one. And so this is where our new vertical asymptote is going to be. So now we need to make that same shape, but we're going to get close to these dotted lines like this. Okay, and so then this shape, this graph that we have down here, this is going to be our final answer. All right, let's do some more examples. Let's do 35. Okay, minus. Okay, we have minus x minus 3 squared plus 5. So first, just like always, let's start with our parent function. So our parent function here, get rid of every single number that's not an exponent. So we get rid of the minus sign, we get rid of the minus 3, and we get rid of the 5. And all we're left with is an x squared. The first one, what we need to do, we start with the things closest to the x and we move out. The closest thing to the x is that minus 3. So our first thing is going to be x minus 3 squared. The next closest thing to the x is that minus sign. And the last is going to be adding that 5. So we're going to have 4 graphs here. Start the parent function, then we have our first, second, and third transformation. So we've graphed this parent function before, the x squared. So we know that looks like the parabola, with that U shape moving upwards. And before we put these points on, 1 positive 1, 0, 0, and minus 1, 1. So here's x squared. Here's our first transform, or just the parent function. So now let's move on to our first transformation, which was x minus 3 squared. So we have a minus 3 inside there, which means we're adding 3 to all of the x values. So here's an x value of 0. We add 3 to it. It's going to turn into an x value of 3. The y values don't change here. It's only the x values. Here's a y value of minus 1. You add 3. It's now an x value of 2. So 2 comma 1. Here is an x value of 1. We add 3. It is an x value of 4 now. Okay, and then we just connect all of the dots. All right, now let's move on to the next one, the minus x minus 3 squared. So this one, now we have a minus sign being multiplied onto the outside of the x, which means we take all of our y values from the previous graph and we multiply them by a minus sign. So here we have a y value of 0. If we multiply that by a minus sign, nothing changes. So that's still going to be the 0.30. Let's erase these arrows over here. Here we have a y value of minus 1. Sorry, here we have a y value of positive 1, 4 comma 1. So a y value of positive 1. Multiply that by minus 1, it turns into a minus sign. 4 minus 1. Here we have a y value of 1 as well. Multiply that by minus 1, and it turns into a minus 1. 2 minus 1. Connect those dots. That's all we got to do for this one. So we took care of minus x minus 3 squared. So now we got to move on to our last graph, which was plus 5 at the very end. So minus x minus 3 squared plus 5. So now we're adding 5 on the outside of the x, which means we take all of our y values and we add 5 to them. So let's erase our previous arrows over here. Let's start with this point right here, the 3, 0. Our y value is 0. And if we add 5 to it, so now it's going to be 5. So we have this point up here, 3, 5. Yeah, that's good. Here we have a y value of minus 1. If we add 5 to that, it turns into positive 4. So we're going to have this point 4, 4. Remember, the x values aren't changing here. It's only the y values. And here we have a y value of minus 1. If we add 5 to that, it turns into 4. So now we have that point 2 comma 4. And then we connect the dots. And that's all we have. And so this would be the graph that we're looking for this one. Okay. Maybe do one more from the section. Let me see, what are the homework problems if we took care of all of those? Oh, let's go. Let's do something like that. So 49, 51, 54. So for this next ones, let's do 50. So what we want to do is we're given like a description of the graph and we want to write what is the actual equation of it. So like for 50, it says the shape, oops. Okay, so we have a shape of square root of x, but shifted to the left 6 units. And down 5 units. So what does this mean here? Well, the shape of the shape of the square root of x. Okay, and now it's telling us two things. We're shifting to the left 6 units and down 5 units. So left and right, that means we're adding or subtracting to the x values if you look above. And it's always the opposite. So if we're shifting to the left 6 units, so left is we usually think of it as the negative direction. You know, we have our axis over here. Here's all the positive numbers. Here's the negative numbers. When we shift to the left, which we usually think of, you know, moving to the left as minus, but when we're talking about moving to the left and to the right, if we want to shift to the left 6 units, we actually have to add to the x value. So let's take care of both of these things separately. First, if we want to talk about just left shifting, so left 6 units, this means we need to add 6 to the x. So it's going to be the square root of x plus 6. This is going to be shifting to the left 6 units. And so now if we want to shift down 5 units from this, so remember if we move up and down, that's just the stuff that happens to the outside of the x. And it's not backwards. So if we're going to move down units, we subtract 5. And if we're going to move up 5 units, we just add 5. So now if we want to take care of, say, down 5 units, if we move down 5 units, that's just going to be the square root of x, and we're subtracting 5 on the outside. So if we combine these two things together, so what we're going to get is the square root of x plus 6, and then we subtract 5. So this plus 6 inside here, this means we're going to shift to the left 6 units, and this minus 5 means we're going to shift down 5 units. All right, which ones are you guys doing? Let me look at the, so 49, that's good. 51, that's fine, and 54. That's good as well too. So let's do one more. How about let's do that one together. So this is a homework one, but we can just do it together. 51. I'm intentionally skipping problems like numbers. Whenever it talks about the word stretch or shrink, don't worry about those words. I think those are kind of confusing. So when you talk about stretch or shrinking, let's just move back up here for a second. For example, I'm not really sure, I don't have the stretches or shrinks memorized what they mean, but this is some type of stretch or a shrink whenever you're multiplying. However, the word stretch and shrink is just kind of like unnecessarily confusing because it just causes you to memorize more things. But if you do it this way, it doesn't really matter if you know what stretch or shrink means. Like all this for this one in particular, all you need to know is whatever that a value is, you just multiply it by the y values, and that's it. I think what the book says is if it's less than 1, it's a shrink, but if it's more than 1, it's a stretch or something along those lines. But it's just more stuff to memorize that doesn't really help you at all. Just doing it this way, I think, is better. Just if you have a number multiplied on the outside, like how this a is up here, all you do is you just multiply the y values by that number. So you don't need to worry about the word stretch or shrink. Back to that page width. No, this one. Let's move back down. All right, so 51, what we want to do here is we have the shape of the absolute value of x. Shape of the absolute value of x, but it's going to be shifted to the left 7 units. And which one are we doing? 51. Shifted to the left 7 units and up 2 units. Okay, so what does it mean to go to the left 2 units? Well, we said when moving to the left and to the right, it's sort of backwards. So if we move to the left, we need to actually add to the x values. And if we move to the right, we're going to subtract from the x values. So moving to the left 2 units really means that we're going to add 2 to the x values. So this is going to be shifting to the left. Now, say if we want to move up 2 units. So it's not backwards when we're moving up and down. If we're moving up 2 units, that means we're just going to add 2. But remember, moving up and down, that's when we add on the outside of the x. So we would have absolute value of x plus 2. And then if we combine these two things together, what we're going to get is x. Oh, I might have made a mistake. Moving to the left 7 units. Sorry, not 2 units. Moving to the left 7 units. So if we move to the left 7 units, it means we're going to add a 7 to the x. So remember, moving left and right, it's always backwards. If we move to the left, we actually add, but if we move to the right, we subtract. So yeah, moving to the left 7 units means we add 7, and moving up 2 units means we're going to add 2. So it's not backwards for moving up and down. It's only backwards for moving left and right. So we're going to have, if we combine these together, we get x plus 7, and on the outside, we get plus 2. Okay. I think that's good for this section. Let's move on to the next section. So section number 2.6. So there's only basically 2 things that we need to know from this section. So what does it mean? I think if you have the book in front of you, this is on page a little bit on 147 and a little bit on 149. But basically, there's 2 things here: varying directly and varying indirectly. So if how do they word it? Okay, so if y varies directly with x, what this tells us is that y is equal to k times x. And k is just some constant that we might be able to find given the problem. So this is what this means. We have y varying directly with x, and then we also have y varying indirectly with x. This is going to be varies directly. We can also have y varies indirectly with x. And what this tells us is this: y is going to be some number k, we don't know what it is quite yet, divided by x. So those 2 things they're given in the book, like on page 147 and 149. Just the ideas of what that means. So let's just do a couple of problems with this. So we need to do 1 and 3. Okay. Well, let's do. I might need a calculator here. Sorry. Sometimes let's change this word. Sometimes they'll do varies indirectly or they'll varies inversely. I think the book's actually using the word inversely here instead. Let's change this word indirectly with inversely. This is the word the book uses. Indirectly or inversely, sometimes it's interchanged. All right, so how about a problem like, let's see, which ones are you doing? Oh, we can do 5 together. Okay, so 5. What we want to know is we want to find k. If so, we have y varies directly with x. And So we're given a point on, basically we're given something, and y is equal to 1 when x is equal to 1/4. Okay, so how do we do this problem? Well, first it says the first bit of information, y varies directly with x. So we know for sure y is going to equal k times x because it varies directly. And if we go up here, that means that it's going to be something like this. And then it's telling us y is 1 when x is 1/4. So we also know that y is going to be 1 to y equals k, and then x has to be 1/4. So we know this. So now we can find k. All we have to do is multiply 4 on both sides. So multiply by 4, multiply by 4. So we're going to get 4 is equal to k, and the 4's cancel on the right-hand side. So we found that our k is going to be equal to 4. It's really not too much to do for this problem. Let's do one example with inversely. Number 10. So number 10 is saying y varies inversely with x. And y is equal to 1/5 when x is equal to 35. So what's going to be the k in this problem? So we know y varies inversely with x. So the first thing we know is y is equal to k divided by x. Second thing is, well, y is going to be 1/5. So 1/5 equal to k. When x is equal, oh, sorry, not an x, that's a k. When x is equal to 35, so we have a 35 up here. So if we want to solve for k, all we do is multiply by 35. Sorry, not 3 times 5. So multiply by 35, multiply by 35. So we over on the left-hand side, we have 35 divided by 5, which is 7. And on the right-hand side, we have the 35's cancel, so we're just left with k. So we have 7 is equal to k. Okay, and the last bit of problems we have from the section, so 25 and 31. What do those say? Oh, okay. The next bit of definitions from this section is what does it mean to vary directly with the square of x or inversely? Oh, let's see, what do we have? Y varies directly with x. So which ones are we doing here? 25 and 31. So there's a couple of other definitions that we needed. We can just actually do both these problems together. So number 25. So what we want to do here is we're basically kind of like just adding on to the previous definition. What does it mean to vary directly with x or inversely with x? So number 5 is saying y varies inversely with the square of x. And we're also given y is 0.15 when x is 0.1. So we said when y varies inversely with x, that just meant y, sorry, not x. Y is equal to k divided by x. So that's what inversely means. But now we're saying it with the square of x. So really all we're doing is we're putting a square down here. So if y varies inversely with the square of x, we're still doing the k divided by x, but the only difference is if it's the square of x, then we're dividing it by an x squared. So there's our equation. So now let's just plug in those points. So we know y is going to be 0.15. So this is going to equal k all over 0.1. 0.1 squared. So let's move up here. So we have 0.15 is equal to k. And if you do 0.1 times 0.1, that's going to be 0.01. And so now to solve for k, we multiply the 0.01 up to the other side. So we're going to have 0.15, 0.01 is equal to k. And if you multiply 0.15 times 0.01, you're going to get 0.0015. So that's going to equal K. We do that right? Yeah, so that's all good. So here's our K value for this one. I mean, the last problem that we needed to do together, let's do 31. So what this 31 is saying is y varies jointly with x and the square of z. And y is equal to 105 when where are we at? 105. X is 14 and z is 5. So when it says varies jointly, it means we're basically varying directly with both these at the same time. So what this is telling us is that y is actually equal to k, and then we're going to have an x and a z. So it's basically like saying we're varying jointly with both of these. Varying directly with both of these. So jointly and directly mean the same thing in this book. The last thing from this problem, though, how it says that, so jointly with x, so we have an x here, but the square of z, so we need to have a z squared. So there's our equation. And now it's giving us a point. It's saying y is 105 when k is there, x is 14, z is 5. So this tells us that 105 is equal to k 14 times 25. And so in order to solve for k, we just divide the 14 times 25 to the other side. So k is going to equal 105 divided by 14 times 25, which is equal to, if you simplify that, you should get 3 over 10. So we get k is equal to 3 over 10. Okay. That's really all we need to get done today. That kind of takes care of all the homework problems. Yeah, there's no questions for the people who came to class today. Feel free. I mean, there's nothing else we really need to talk about. Yeah, other than that, I'll see you guys in here tomorrow, and I'll post this video on YouTube once it's done loading on my computer. Okay, cool. All right, well, thanks. Have a good one.